All right, we are going to get some practice naming these formulas. I have a number of formulas here. We're just going to go through them fairly quickly. And this will give you an idea of what you need to have memorized and work on. All right? So here we have calcium and carbonate. Okay, so we need to recognize that this is an ionic compound. It's made from a metal, calcium, and then a polyatomic ion there. And so we put that together, calcium. Now calcium, what's the charge of calcium? It's positive 2 because it's in that second column, the alkaline earth metals. And then carbonate is negative 2. But we don't need to put Roman numerals for this because it's in that given column. Okay, so this is just calcium carbonate. Okay, now this one, again, first thing we need to recognize whether it is an ionic compound or molecular compound. And here we have nitrogen and oxygen together, two nonmetals, so that's a molecular compound. And therefore we use the different rules where we use the Greek prefixes. So this will be dinitrogen tetroxide. Okay, always ending those ones in IDE. Now here we have a metal and a nonmetal, so this is an ionic compound. So we need to look at that sodium. We know it's in that first column, so it has a positive 1 charge. We know what its charge is, so we don't have to write that in the formula. This will just be sodium oxide. Okay, monatomic ion, so we end that in IDE. Okay, here another another metal and a polyatomic ion. This one is aluminum, and then PO4 is phosphate. You'll notice in these, for most of these, we won't need to worry about the charges because we're given that these are correct formulas. All right, now here you recognize two polyatomic ions. There's NH4, a cation, polyatomic cation, and then a polyatomic anion, NO3. Now, the rule that, if we look at and we have two nonmetals, that makes it a molecule. And here you might say, well, nitrogen, hydrogen, nitrogen, oxygen, those are all nonmetals. But we have to remember that these are two ions, the ammonium ion and the nitrate ion. So this is an ionic compound, and so we're just going to name it with the names of each of those ions, ammonium and nitrate. Okay. Here we are looking at rubidium and fluorine, and rubidium is a metal with a nonmetal. So again, this is an ionic compound, and rubidium is in that first column. Some of these I wouldn't put on the test just because I don't expect you at this point to know the whole periodic table, but for practice purposes, I'm putting them here. Okay, so monatomic anion, we end that in IDE. So PF3, phosphorus and fluoride, both of those are nonmetals, so this is a molecule. Phosphorus, only one of them, so we don't put the prefix. Phosphorus and then trifluoride. Okay. Now here we have titanium and oxygen. Titanium is a metal with a nonmetal, so this is an ionic compound. So we name this as titanium, but then we have to look and say, okay, do I know what the charge of titanium is? I know from this formula that I have 2 oxygen. Each oxygen is -2, so that would give me -4. So the titanium must be +4. But titanium is a transition element, number 22, and therefore we don't know just from looking at it on the periodic table what it is, and so we have to put those Roman numerals with the charge, titanium 4 oxide. All right. Now here we have iron and then C2H3O2 2. Right? So we need to recognize this as acetate, and this will be iron, and then what's the charge of acetate? It's a -1. We have 2 of those, so that would give us -2 for the 2 anions. That must be balanced out by the iron at a +2. So this will be iron 2 acetate. Okay. Here we see sulfur and fluorine, 2 nonmetals again. So we have just one on the first, but that's the first one, so we don't use the mono. This will just be sulfur, and then 6 is hexafluoride. Okay, ending that always in IDE for the molecules. All right. Now here we have manganese and sulfate. Right. Manganese is another transition metal, which means it can have a variable charge. We don't know what its charge is offhand. But if we look at this, this is Mn2SO4 7. Okay, so we have 7 sulfates. Each sulfate is a -2, so that gives us -14. And that is balanced out by 2 manganese, so that gives me each manganese must be a +7. All right, so this would be manganese in Roman numerals in parentheses 7 sulfate. Okay, and here we have gallium and sulfur. Right, gallium is on the underside of the line that separates the metals from the nonmetals. So this is a metal with a nonmetal. So this is an ionic compound. And the charge of gallium, it's in the 3rd column there, the same column with aluminum. And therefore its charge is +3. Okay, we know its charge. And so this is simply gallium sulfide. Okay. Here we have beryllium and chlorine put together, and beryllium is the 4th element. On the left, it is a metal, so this is an ionic compound, beryllium, and its charge is given by the column that it's in. It's in the 2nd column, the alkaline earth metals. So this has a fixed charge, and we don't put its charge in Roman numerals. So this is just beryllium chloride. Okay, monatomic ion ending in IDE. Here we have vanadium and selenium. Okay, selenium is a nonmetal and vanadium is a metal, so this is an ionic compound. And vanadium is a transition metal. Okay, so this one we have to specify the charge. We don't know it offhand, but we can look at the formula and say, okay, selenium is in the same column with oxygen and sulfur, so it has a -2 charge. I have 5 of those, so that gives me a -10, and I have 2 vanadium to balance that out with a +10, so each vanadium must be 5. Okay, so this would be vanadium 5, and then selenide. Remember, it's a monatomic anion, so I change its ending to IDE, vanadium 5 selenide.